Bruh. Hello, gamers. Hope everything is going okay on this fine Wednesday. I managed to publish a couple of the VODs for last week's stream, or the other stream at this point. I have absolutely no idea. I completely lost track of the VODs. But yeah, the last the two VODs that I published are the ones about writing the text viewer app for the getting started tutorial in Python, and they are both up. Yeah, I think we're missing a couple of streams. The stream on last Friday and the one on Monday this week. They will be up probably tomorrow. Just need to do a couple of tweaks on the one on the stream from Monday. So I should be fine. Yeah, after that I should be able to, I should have caught up with the current backlog. Yeah, the main problem was the stream. I had a stream that I had to do some video editing on top, which means downloading instead of having Twitch basically publish directly to YouTube, so using their backbone to upload 8 GB of video file, I had to download it on my machine, do video editing, transcode it, render it into a video that is suitable for YouTube, and then upload it. And in the middle of it, my home connection just went down, so about halfway through it. Hi, Alatira. So I had to redo it. I had to re-download it as well, because I deleted the file without checking, and then I had to re-download it and then re-render it and re-upload it. I mostly need a way to find out how to publish how to drive a little more traffic to my YouTube channel. It's not because I want more subscribers, but mostly because I want more people to give feedback on that, on what they want and what they care about in terms of content for GNOME. Because I can keep doing streams like this for basically ever, but if people want more specific topics, then suggestions are always welcome. Like leaving comments on the VODs or joining here and leaving a comment in the chat. It's perfectly fine. Sorry, no caps. But yeah, again, if people want to have like, I'm also entirely open to like opening the floor to like generic questions about GNOME development, not just documentation, but everything else. If there is a topic that I know anything about, then I'm happy to comment on that. I'm happy to do it. Otherwise, I'll start playing some game. I had to go back to about playing games. I had to go back to X11. I finally managed to make OBS work on Wayland with my NVIDIA GPU. It turns out that there was OBS plugin that I installed, and it basically just screwed up the I don't know, the startup sequence. So I had to remove a bunch of plugins one by one to figure out what the problem was. And I managed to make OBS work under Wayland with my Fedora Silverblue installation and an NVIDIA GPU, and it worked perfectly fine. I had to change one element, the desktop the monitor capture element, used the pipewire one, and it worked perfectly fine. It looked great. My main problem is, well, there are two problems. I cannot use Wayland with my NVIDIA because currently, or at least on Fedora 35 and GNOME 41, the nightlight is currently broken on NVIDIA, which is sad because I tend to use my computer late in the afternoon, evening, and sometimes even night, which means that the nightlight is the only way that keeps me moderately sane. And the other problem is that using Wayland, my computer decided not to suspend anymore. It would turn off everything, but it would stay up. I think there's a bug somewhere in the, I don't know, user session somewhere. Maybe, yeah, clearly the GPU driver was not suspending, and the end result was everything just stayed up, which is not nice. I can keep my laptop running overnight. It's perfectly fine. It's a very simple laptop. It's plugged in, doesn't consume that much power. But my desktop machine has 4 fans that are basically constantly spinning, low speed, and you cannot hear them because OBS is doing a filter pass, so it's denoising the entire room. But yeah, I cannot let it run. Also because, yeah, it consumes a ton of power. So I'm not gonna run. I'm not gonna let my desktop machine run overnight. So I'll have to live with X11 for a little while longer. At least until GNOME 42 is out and Fedora 36 is, if not available, at near release. won't take long though. We are about end of the week is going to be code freeze, and in 2 weeks time is going to be, well, yeah, 3 weeks, well, 1 to 3 weeks basically, less than 3 weeks, we're gonna have GNOME 42 out, which is going to be amazing. I read a comment on the GNOME subreddit saying, "Oh, there's no Nautilus with GTK4 in GNOME 42. Well, I guess it's okay. It's not a great release." And my first instinct was, "Well, fuck you." Sorry, the monkey couldn't like dance for you. Jesus, the entitlement. Just, oh, 6 months. Ported a bunch of applications to GTK4, did an entire refresh on the shell UI and icon theme, entire new websites and documentation and releases. There's a complete library for the platform in libadwaita, and well, I guess it's fine. It's not incredible. Oh, hi, Bilal. Yeah, and yeah, GTK4 was, yeah, already everything. GNOME 4. Yeah, GNOME 4. No, sorry, it cannot be GNOME 4. GNOME 4 wasn't purple enough. It needed more purple. Bit of inside joke. For former employees of a company that shall go unnamed. Orange and brown, yeah. I still remember when Ubuntu was mostly orange. Wasn't even brown. It had some brownish tones somewhere, but it was mostly orange. Then it got progressively darker, and then like funeral colors with that purple and gray and black. I have no idea why that happened. I don't know, it never enticed me. I think I installed a Ubuntu version when Unity was still a thing, and the canonical hadn't switched back to GNOME, and I was shocked about the darker tones used everywhere. Was very, I'm not feeling very welcome here. Don't know, that was the first feeling I got when I tested when I installed it and launched it. It wasn't even a dark theme. Like these days we have dark themes, and mostly we kind of, a lot of people like it. So you have a dark theme and stuff, but that one was just grim. I don't know, I'm Italian, so every time I see something that is purplish, like violet purple, it's, for me, is color of a funeral. So it's very it's bad luck, you could say. So I have no idea what possessed the canonical designers to choose that particular color scheme. Emo was a growing market. Oh, it was too late for being emo. It should have been like early 2000, like with My Chemical Romance or something like that. But yeah, it should have they should have pushed for that particular market segment, emo teens. Oh, thank you for the follow, M for Hele. For Hele. Let's get to 150. number go up. Right. So, let me check that out. Right. Yeah. Soon I will be able to not have to move my head to the other screen to use OBS with my mouse, because I joined the ranks of the owners of a Stream Deck, like George's as well. I got this tiny little device that has like 15 buttons with a small screen on it that you can program to do stuff. It's very nice. It's very little. I was scared that it would be like massive, but it's fairly small, and I will be able to press a button right in front of me without having to like move my head or my eyes. I'll keep eye contact to assert dominance with the people watching me. Oh. Right, so let's switch to my desktop. So on Monday I started working on, I went back working actually on the tagged entry widget for libadwaita. And well, mostly because I wanted to close this, but I realized that the design could have been better. So the first iteration was a very simple, here's a widget, here's the details of a tag, and then just create it in a way that is kind of reminiscent of a stack. So you add a tag with a name and then you manipulate the tag object that it returns. Turns out that the design that other platforms actually use, like Android or iOS or AppKit, is fairly different, is more similar to the Toast API already in libadwaita. Which means I have to redesign the entire thing. So first things first, I made the tag object a little bit more complex and separate from the actual tagged entry widget. So now you can create a tag object and you can set a label, you can set whether or not it should have a close button, and the icon using a GIcon object. GIcon is just an abstract icon object that is an icon interface that is implemented by things like GDK Pixbuff or other icon-like things, like if you ask for the icon that represents a file, you get a gfile icon, which is a GIcon. So you can use an actual like MIME type or whatever. But also if you have, I don't know, a user avatar or whatever else, you can use that. We could also modify it a little bit and take a paintable at some point. That would also be usable. A paintable would allow you to set any GDK texture or even a widget or something that can be animated. So right now I'm going for an icon, but maybe in the future I will add an API that sets a paintable. And then you have an action name and the target value, which means that whenever the user will press the tag representation, you'll get an action emitted. This way you can intercept that without having to have a signal like clicked on an actual widget, which is going to be fine. Again, this is kind of taken from the Toast API in libadwaita. I mostly need to implement all this stuff, so this is what I will do today. Another thing that I will implement is the representation, the widget representation of this. So this is going to be our model object, and then we are going to have a view object, a view widget that will essentially take the state from this object and then represent it to the user. The widget will be private, at the very least for now. I'm not entirely sure it's going to be usable if it's public, but for the time being it's going to be private. And the overall idea is that we'll have a set of widgets that can take a tag object. One of them will be a simple tagged entry, which is what we are trying to achieve. So the overall idea is that you can add a bunch of tags to an entry using additional UI. So you use it to type stuff in, but the tags are added from the outside. But another thing that we can do, and we should probably do, is using a tokenized entry. Basically, you start typing, and if you type something that is recognized as a tag or a token, then we'll take that, remove it from the entry, and create a tag and add it at one of the edges, the leading or the trailing edge of the entry. Most likely the leading edge of the entry. And that one allows us to implement something like the recipient field on email clients that exist on mobile devices or on Gmail. So most of the time you start typing an email, and if that email address matches one of the email address in your contact list, then Gmail will remove that and replace it with a tag that contains like the avatar of the user and then the avatar of the recipient and then the name of the recipient instead of the email address. So I was thinking about an API like that. So basically you're going to have a widget that will have a list model with all the possible matches, and then we'll have a filter function, well, not a filter function, sorry, a matching function. And every time you add something, then it will tokenize it. So it will take everything up to that, to the last space, for instance. And then it will take it and it will match it against the elements of the list model that you pass to it. And if it matches, then it will create a tag and put it there. That would be an interesting demo and also an interesting widget to have. But it's also something that it's useful if you're like writing some form of tagging UI. So you have an entry, please enter like your tags, and then you start typing, and you whenever you press space, what you typed gets turned into a tag, and so on and so forth. There are a few examples of this in the the few examples I know are inside the YouTube channel editor, the video editor that exposes the whenever you have a YouTube channel and you have to edit the details of your video, you can also tag the video, and tagging the video is exactly that. You start typing a tag, and then when you press space, the textual part gets replaced with pill box. So a small tag widget that has an icon and has a close button. So close button will remove it, and basically lets you add a bunch of tags to a video. So implementing something like that in libadwaita would be neat. So let's try and see what we can do today. First of all, we are going to open our tag source code. We have a bunch of properties already here that we've taken from we actually took them from adwaita toast, the toast object. The close button by default is true, so we have to set it true, so it's fine. So we are going to go back to the header file and just take the declarations for the API that we currently do not have. And then we're going to implement it. So it's going to be available for us. The eagle-eyed among you might have noticed that I am using GNOME Builder 42 beta. Yep. From Nightly. Mostly because I wanted to start having a look at the templates for new projects. I've done a couple of changes there, especially in the Python templates and the JavaScript templates. The JavaScript template is still work in progress. I'll have to finish it. I open a merge request, but I have to finish it later on, so we get an updated version that uses an implementation that looks more like the other languages that we use in getting started documentation. Hi, Georges. I mentioned the Stream Deck and you join. Okay. Yeah, before switching to libadwaita, I switched for a second to boatswain, and I'm probably gonna work on this as well. Well, soon. I already started working on a launcher action, so you can launch applications from the deck. Mostly because I noticed, rewatching a bunch of my VODs, I noticed that I keep having to go to the overview and then select a launcher and then launch an application and stuff like that. And it's always basically the same. And I don't want to switch too many times, especially on stream. So adding a launcher to the button would be nice for me. So I'll keep hacking at that. Implementing folders. Oh. Yeah, I've seen that they are basically just P's extension, and I kind of know how to implement those. And also the dummy plugin is useful for that. Well, I'll definitely reach out. Okay, so getting the icon. And we fail. And then we can return the icon here. Oh, come on. Fail, icon equals null, or and this is going to be the usual gset object. G object identify by Pisca. Okay, this is the trivial stuff we are going to have here. And this one is going to be our get property. For the action name and target, we are going to look at toast. Mostly because, again, it's pretty easy to just reuse this code here. Oh, there you go. Wait, what? No. You shouldn't be calling the public API. Let me see. Action name and action target. Yep, that's fine. Yeah, it's so this is kind of a matter of taste. The implementation of the get property virtual function for your GObject class should always call the public API for setting properties, unless they are construct-only properties. Construct-only properties cannot have public API because they can only be set during construction time, and so there is no public setter for that property. That cannot be a public setter for that property. But for getter, the get property implementation should do direct access and not call into the public API, mostly because you cut down a type check. So the main difference is this: the public API for setting a property is going to do some form of validation on the value that you're passing. It has to do it because it's public API. It has to do validation. There is also validation done at the GObject level for some stuff, but for the rest is going to be just deferred to your public API, which is good. The getter API, unless you're computing the value of this property, then you should not be calling into the public API. You can save time. You can save like this bit. GObject set and GObject get are already fairly expensive because of implementation details. Don't add to that cost, the cost of calling into public API, when there is really no point in doing that. After all, like literally this function does a type check and then returns a pointer here. What's the point in doing that? You can just return the label yourself, for instance. Let's go inside the Toast API instead and look at the implementation of this stuff. Yeah, it's the same stuff here. So literally don't do that. And same for this. Yeah, these setter functions are more complicated. They do additional stuff. So but yeah, so let's go back inside our tag. This one is going to be return returns null. Action name cannot be null. And this one is going to be prop bag name. Okay. And then we can do the same for the action target. Okay, let's go back to our tag. This here. This is going to be our okay. And this one are, these two are going to be built like this. This one uses the same kind of functionality that I used in the toast new format constructor that I worked on the other day, on Monday. Okay. So all it does is please collect everything that comes after format string into the args list, VA list of the data structure, and then create a G variant using that information and then feed it to the set action target value. This is actually a bug though. You should sync it. You should not ref it. This is this is a bug. So let me get you there. So if you want to sync, this is going to be fun to explain. So glib and gobject use reference counting. Reference counting is a garbage collection technique. It's the dual of any other tracing garbage collection mechanism. So you have tracing garbage collection, which basically just keep track of every user of a data object, of some object or some data structure basically, and then collect when the last reference goes away, basically last user, not last reference. Reference is probably just how it's implemented internally, but that's not important right now. But then you have reference counting. Reference counting defers to you instead of to a separate mechanism, whether or not you acquire or release a reference to a certain object, certain data block. So they both are garbage collection mechanism, but one is automated and it's internal to the runtime of the language or library that you're using. The other one instead is explicit. It's up to you to acquire and release references. There are other complications, there are other mechanisms. For instance, reference counting is explicit in the sense that when you drop the last reference, when you release the last reference on some data block, the data block is freed, all the resources are freed. Whereas the garbage collection using tracing is it can defer the free operation to another thread, another cycle, or keep it in limbo until maybe it gets used again, the memory gets used again somewhere, and it recycles it, and so on and so forth. That is entirely unimportant right now. The important thing is reference counting is garbage collection. So normally when you create an object, you give out the object with a reference count of 1, because it's the ownership of the reference gets transferred from the constructor to you. So you create like GTK box, an object, GTK pixbuff. GTK pixbuff new return gives you an object that has a reference count of 1. So if you then call gobject unref, so you release the reference that you acquired, the pixbuff object gets deallocated and all resources freed. This is the typical use case, and it's fairly well defined, and basically everyone can immediately grasp the nature of reference counting this way. Of course, it can be complicated. It can get complicated. We are software engineers, we are programmers. We live for complicating simple ideas. Because let's imagine you have an other object that acquires a reference on the object you just created. Let's say you have a box and then you want to add a label to it. If you do that, normally it means that you call, for instance, GTK box append on the label widget, and then you have to call gobject unref on the label, because now you transferred the ownership of your reference. So you basically moved the reference from your possession to the parent widget. In higher level languages, this is trivial to do. It's perfectly fine. In C, it gets noisy, because now you have to do, for instance, GTK label new, then take the label and call GTK box append, and then call gobject unref. And you have to do that every single time. So one brilliant thing that the creators of GTK originally and gobject after that did was, why not have an object that has a reference at the end of the construction sequence, but that is not a real reference, is a floating reference, something that is both is and isn't a reference. So you expect that reference to be consumed. You basically expect that reference to be transferred from you to the parent container, because of course a widget without a parent container doesn't appear on screen, is pretty pointless. The only thing you can do with a widget is adding it to a container. And this is how floating references came into being. So you create a label and then you call GTK box append on that label, and then you don't have to call gobject unref on it, because that reference is transferred, sunk. So the floating reference is turned into a real reference without having to increase the reference count. That was a mistake. That was a terrible idea. And we are still paying the price of that terrible idea now, 20 years later. God, that was a mistake. It's a mistake because it complicates everything. Now you have to take into account that widgets are created with a floating reference, which means that you get to destroy them, maybe. Well, you get to, if you drop the reference, what happens? Who knows? It's not a real reference. It's a reference that's supposed to be sunk. Language bindings love this concept. Not. They fucking hate it. I'm surprised that in the future. So this is how I know time travel don't exist. Because if time travel existed, language bindings authors would have sent somebody in the past to kill anybody who invented the floating reference idea. So this is how I know that time travel doesn't exist. Either time travel doesn't exist, or humanity ceases to exist in any meaningful way before that happens. So this is how I know that. Because like all memes, floating references have infected other parts of the platform, and one of them is gvariant. Gvariant has a ton of functionality predicated on the existence of floating references. One of them is if you create a gvariant with gvariant new and you pass that gvariant to any other gvariant API, typically that gvariant will be sunk by the callee with gvariant refsync. Refsync is an atomic operation that will either sync the reference, so turn a floating reference into a full reference, or it will acquire a full reference if the object was not floating. I'm going to find all the gemstone to undo floating reference. Yeah, it's and also entirely possible. I mean, I don't strictly believe in the branching time travel theory. I strictly believe in the self-consistency principle. So you cannot change the past because it's the past. And if you try to change the past, you would have made the past. But yeah, that we are going into time travel discussions here. Something that I never expected to happen in a stream about writing code. Best kind of discussion. Yes, it is. But yeah, so gvariant, every time you do this, you should be using gvariant ref sync, not gvariant ref. So this means that there is a subtle bug in the Toast API, because set action target value should be calling gvariant ref sync. Here. I'll file a bug. Well, I file a merge request actually, but yeah. But yeah, the bug is subtle. But essentially, if you call set action target value with gvariant created with gvariant new, then you're going to leak the variant. I don't know if you're going to leak it or gvariant will essentially tell you when you do gvariant and ref here, you're doing something wrong. Stop doing it. It should be the case though. I have to remember to do that anyway. But yeah, so every time you implement an API that takes a gvariant, and you should also document that the past gvariant will be sunk, so you can call it with gvariant new inline here. But every time you do that, the correct thing to do is called gvariant refsync here, and never use gvariant ref. You should only use gvariant ref if your acquiring a reference on a gvariant that you know it has already been sunk. So you require that the gvariant it does not have a floating reference, in which case you should add a check here saying the gvariant should not be floating. But at that point, what's the point? Just always call gvariant ref sync. And this one we are going to copy the code as well from here. I have to admit, I'm so sad that I'm really sad that we had to remove the gauto pointer from libadwaita. I need to remove the null here. Why was that? It's because people want to run libadwaita on Windows. Well, they want to run GTK4 libadwaita applications on Windows. And since MSVC does not support the cleanup attribute, it does not support auto pointer. And I'm so very sad. Yeah, Windows killing are fun. Okay. Yeah. Okay, this is fine. So this API is going to be fine. I'm going to modify quickly the meson build to remove the tag entry widget from the build, so we can just build a tag and see if everything is correct. Yeah, okay. Oh yeah, I'll have to also modify the demo build so I don't actually build the tagged entry demo. I don't want to deal with that right now. And this. Okay, we have a couple of things to fix. Tag here. Where are you? Yeah, here. We also gonna add the API here. Here we break. Okay. And we have a the tag props is not props here. There you go. Okay, let's see if it builds. Yeah, it's annoying having to support MSVC. It's 182. It's annoying to have to support MSVC for that reason alone. I'm not against supporting MSVC because it's useful to have people oh yeah, here 129. It's annoying to have that. Yeah, that was gonna be my point. MSVC, the MSVC toolchain is a lot better than MSys or MingW or whatever. It's not even funny. You get proper debugging, you get a bunch of other things. Demo window. It is where is it? Yeah. It is so much better. Not having to deal with that is a lot better. You get proper debugging, you get proper ID, you get a bunch of other things there. So much more well integrated with Windows as a platform that it's a lot better. The main problem I have is that MSVC as a compiler kind of sucks. As a C compiler, well, MSVC is the C compiler, so as a C compiler, MSVC is quite frankly terrible. It would have been nice if the effort to replace the MSVC core compiler with LLVM succeeded, because then we would have only a couple of compilers to care about, and CLang and /LLVM are good compiler. It's a good C compiler with a good amount of feature support, especially features that we care about, like the cleanup attribute that we use to implement the auto pointer macros. So whenever a variable declared with the cleanup attribute goes out of scope, then you can call into a function that will clear up the memory. So you can say goodbye to leaks, and you can also say goodbye to complicated error code paths. Makes writing C code a lot easier, which has its downsides. People start picking up C. People should not be picking up C in 2022 for anything, I have to admit, unless they're writing a GNOME library, in which case, please use C. Okay, so the build with the build folder tag went well, so we are okay. So now we have to create the representation of a tag. So let's create a new file and call it widget tag widget private. For the time being, it's going to be a private widget. So lgpl. Let's use my name. Let's remove my email. But also we are going to use spdx file copyright text. 2022. And there we go. So this widget is going to be private for the time being, so I'm not going to add random stuff. Okay, what the hell? We're also going to include GTK because it's going to be a GTK widget, and it's going to be w type tag widget. And we declare final type. And it's going to be a GTK widget. For the time being, we are not going to add to it any API. We are going to call gObjectNew at this point, whenever we need it. Maybe at some point, if we make it public, if the widget's going to be part of the public API, then we are going to add stuff to it, add public API to it, like an constructor that takes a tag, for instance. But for the time being, it's private. We can leave it there. And then we are going to create a new file and call it widget. Okay, still my name, no email address. Also, yeah, that was kind of dumb. I need to modify. It's not gonna be LGPL 3, it's gonna be LGPL 2.1. So we include something.h, and then we include a widget header, and then we include adw tag private as well. Okay, so the tag widget is gonna be a widget here, and we are gonna add a reference to the tag there. Then we're also going to need the widget reader. So this is going to be a widget class that has a box layout, and then we are going to add a GTK image for the icon, GTK label for the, again, label, and GTK button for the close button. So we define type. Yeah, okay, that's fine. We need the widget class pointer. So we can do GTK widget class set layout manager type. Okay, We'll also need an accessibility role probably, but for the time being, we can skip it. I actually need to check on the... Yeah, this is going to be a group. So it's going to be literally a box. So we are going to have to add a specific role. I need to check. There we go. It's going to be a group. Yeah. Yeah. And we are also going to add set set off. Oh, this is a bug. Oh, this is a bug in GI DocGen. Nice. Yeah, I have to remove the here. Widget class set. This is an interesting bug. Okay. Set CSS name. Okay, so we are gonna call it this way we can style it using the tag element. Okay. Value tag widget unit. So ideally at this point we might also use like a UI file to describe this widget, but since I'm going to go back and forth in constructing the UI to test how it works, I'm not going to do that right now, but it's going to be the next step. So we're not going to use a template for this right now. Okay, so we are going to add self icon. It's going to be a GTK image new. We need to cast it here. GTK widget set parent. Okay. Then we're gonna add the label. And then we're gonna add the close button. Where are you? Just get button new, new from icon name, because it's gonna have symbolic icon. And the icon name we are going to use is going to be the close one. So come on. It's going to be a close button icon. Let me see if I can find it. Window close symbolic. So, well, yeah, it's going to be window close symbolic. So this is the nice bit of GTK4. In GTK3, subclassing GTK widget would have been prohibitive. It would have required me adding a ton of API, a ton of implementation. And then I would, instead of doing that, since, well, this is a container, so I couldn't have subclass GTK widget anyway. I would have had to subclass GTK container, and subclassing GTK container would have required me to add fewer things, but still a lot of things. At which point, people typically use GTK bin as a base class, which is a container that only has one child. So you subclass GTK bin, you add a GTK box inside it, and then inside the box you pack all your children widgets. And then it gets complicated with styling, because now you have an intermediate widget in between yourself and your children, and that can lead to weird results there. In GTK4 instead, it's a lot easier. You just subclass GTK widget, and then you say, oh, I want to impose a layout on this widget that looks like a box. So it deals with things like left to right and right to left text direction, accessibility, and other things. And then you just parent the children directly to yourself. They will be laid out correctly using the box layout algorithms. It's gonna be fine. So there is no reason why you shouldn't create your own custom widgets in GTK4, because it's a lot easier to do. We made it easier to do for a reason. Okay, so this is a good representation, but now we need to bind the tag object with the tag widget. So in order to do that, we are going to use a property for the tag. And we're going to do plus that property. And we're gonna add them there. This is a set, so it's going to be constant value. Okay. So to implement that, we'll need the usual boilerplate. So we are going to do props, spec object, nothing, ADW type tag, it's going to be read write, and then it's going to be gparam not spec construct gparam static strings and gparam explicit notifying. That's a mouthful. Okay. We are going to also need the object class dispose. So we can drop a reference on everything, and we also need to unparent our child widgets. So it's going to be gObject class and then get here dw add widget object. Okay, view clear enter self icon GTK widget and parent. And here. And then gclear object path tag. So unparenting the widgets that you parented yourself into your instance in it is a requirement of GTK4. So in GTK3, this happened because you derived from GTK container. GTK container, its default destruction sequence cleared all the widgets that the container knew about. GTK4 doesn't have GTK container anymore. The widgets are tracked inside GTK widget, which means that by the time you chain up, so you traverse this, dispose goes up to GTK widgets dispose, which is the parent class. The widgets already exist. The main problem is that if GTK widget removed those widgets for you, there would be still the chance of re-entering the dispose cycle, and these pointers would not be clear. They would point to garbage memory because the widget would have been removed by GTK widget itself. And that could cause crashes. That could cause, in general, segfaults, unless every time you added a widget here, you also added a weak reference to the widget, so the you would be notified that the widget went away, so you can clear your pointer there. You can nullify the pointer. There is a simple API that does this. That is called gobject add weak pointer. That basically nullifies the pointer to an object that has whenever it nullifies the pointer to the object that has a weak reference to it. So once the object drops the last reference that he last strong reference that he has, all the weak references get removed. That's a lot of bookkeeping for something. So the compromise for that was, once you get inside your own dispose function, unparent your widgets. And GTK would basically, once you unparent them, you can nullify the pointer. So if you re-enter inside dispose, you're safe. The other option would have been to say, we remove the widgets inside the GTK widget finalize. But once you get into the finalization, the instance has basically just completely been nuked, or most of it. So there's the risk of removing a widget inside the finalize that has, as a side effect, a reference to some other memory that was released during the dispose. The reason why gobject has two as a two-step finalization, or basically just memory release process, is because reference counting is prone to count reference cycles. Object A references object B, which references object A again. In order to break those cycles, you have to remove the reference from whenever you drop reference object A, you have to drop reference B, which will then end up again in object A. But since you remove the last reference, then object B will also be dropped. At that point, you're safe to free the resources in object A and or object B, because you went through the cycle twice. Basically, you can enter inside, you can re-enter inside the dispose implementation the same amount of times as the number of potential cycles that you have with other objects. So you can re-enter dispose once, twice, 37 times, a billion bajillion times. It doesn't matter. If you have a ton of reference cycles, the dispose is what saves you from that, which is also why you have to nullify everything that you release, so you don't end up releasing it twice, for instance, or doing a double free or double unref. Okay, so we have the dispose. Let's go with the widget. And we call it gvalue get set object. Let's see. We only have one property here. So and it's going to be tag widget set tag. Okie dokes. So at this point, we only need to implement our set tag. Since this is going to be, let me see. Yeah, let's do this way. It's going to be a static one because we're not going to have public API anyway, so okay. Yeah, that's fine. So if g set object fill tag, okay. Identify by the spec so this is just the usual boilerplate, but now we need to set up the widget to track what the tag says, what the tag does. So in order to do that, we will use a bunch of bindings. So okay, so the first and most trivial binding is going to be this. Okay, self let's see, show close. We are going to bind it to the visibility of the close button. And for that, we will need to go into blocks, GTK, GObject. I wrote this code and I always forget this stuff. So we'll use default and sync create. Basically what we do is whenever the show close property is set to true, then we want to show the close button. If the show close property of the tag is set to false, we want the close button to be hidden. Pretty trivial. The binding default value means that the direction of the binding goes from the tag to the close button and not vice versa. So we don't want to change the tag object when we change the close button visibility. That's kind of pointless. The close button has a private widget, so there's no way to influence that. But to avoid any particular case of fuck up, we are going to go in one direction only. The other thing is we use gbinding sync create. So the default state of a binding is not to use is to only change stuff on notification. So only if the show close changes value, we are going to update the close button. But we might add a tag with an initial state, which means that we want to synchronize the state of the object as soon as we add it to the property. And this is what the gbinding sync create flag does. The other thing that we want to do is gobject bind property. We want to bind the icon property to the let me go here, image, and here we go. We want to bind the icon, since it's a G icon, we want to bind the icon tag to the G icon property on GTK image. So G icon here. Again, monodirectional binding, not bidirectional, and then please set it as soon as. And finally, we want to bind the property of the tag, the label property of the tag, to the, and I always forget this, label, GTK label. Same thing. So right now we are requiring that the tag is never null. So we always call gObjectSet with a valid tag instead of calling it with null. Null is a perfectly valid value, but we really want it to be that way. So we are going to hide all of this stuff behind a null check. We don't need to undo the binding because gObjectBind property has automatic memory management, so it will keep a weak reference on the source object and the destination object here, and whenever one of these two goes away, so gets dropped, then the binding is instantaneously released. So we don't need to do particular memory management there. Okay, this is a pretty standard fare for a simple view widget. A simple view widget is nothing more than take the properties of the model and then add widgetry to reflect those properties. It's pretty trivial stuff. So let's add it to the build, shall we? Okay. This is going to be VW tag widget. That's it. Since it's a private widget, we don't have to add the header file anywhere. So let's build it. Okay. We have a few errors here. Oh, it's not an image, it's an icon. Where are you? Tag widget. That's one. Okay. Oh yeah, right. A pain in the butt. Okay. We'll have to change this stuff once we get into the that template. Let's remove this. Otherwise, casting is going to be problematic. Variable. Okay. GTK label new takes null, and gparent constructor doesn't exist. It's construct. It's constructor only and construct. Why do we have this kind of stupid inconsistencies in our code? Yeah. Oh yeah, we need to add... Well, it's fine. The introspection stuff is, for the time being, is inconsequential. We're gonna fix it when we document the entire thing, anyway. Okay. And that's the tag widget done. It's pretty trivial, as I was saying. It's entirely not complicated to deal with this stuff. Okay. So now we have our tagged entry. The tagged entry API is going to be different now. Yeah, we'll have to remove most of this API anyway. So a tagged entry, as we defined it, is going to be kind of a simple API. It's going to be just an entry, and then you have API to add a tag or remove a tag. But instead of using name versions, we will use the actual tag object. So we are going to have something like this. It's going to be abw tagged entry add tag. And then okay, something like this. So instead of having a stack-like API where you add a tag with a name, and then you get the tag created on the as the return value, just like in GTK stack, you add a new page and then you get the stack page object at the end of the process. You cannot create a GTK stack page instance by yourself. In this case, we changed that, so we only allow you to add new tags and remove tags using a tag object, a real object. Okay, so we are gonna go back inside the tag widget implementation, not the tag widget implementation, the tag entry implementation here. And we're going to restructure a little bit the entire thing. So the tagged entry is a text entry and a tag box. The structure, I decided to move the tags from the trailing edge of the entry to the leading edge of the entry. So we're going to do something like this. We're also going to remove this. Okay, everything else remains the same, pretty much. So we keep the tags there inside a list store anyway. We also don't return the tag, so we can do this. And we also remove this. And we also remove this stuff. Okay. This stuff remains exactly the same. We are going to remove this. We are going to remove this and this. Okay. This stuff remains the same as well. Okay, so since this is going to be a box again, we add the tag box first. We have a minimum amount of children per line, which is set to 4 right now. We'll probably add API to do that, to bridge that from the outside to the inside. And we add a class to that box. Okay, and then we add the text. Okay, and then we add the list model here. So add tag. Okay, we are going to remove this, and we're going to remove this. Since we are not going to return anything, we can remove this. We are going to still check if there is the same tag. So call it writer if writer equals tag. This should not happen as part of the regular set of operations, so we're going to just remove this. And we're going to do this. Okay. This is just mostly a validation. I haven't entirely decided if I want to allow duplicate tags. After all, if you add a tag, it will create a widget for that tag. So you can have multiple views for the same tag anyway. And then the tag is going to be here. Okay. I'm also going to mirror. So we are going to compare it. So for the time being, we're going to just remove the item from the list store. But we'll need to bind the tag to the tag widget in a way that makes sense. So we'll need a way to map the tag to the widget that we just entered without having to iterate over the children of the flow box to remove the tag that matches it. And we'll see how to do that in just a second. Okay, glist model here, remove all tags. I guess we can keep this API here. Let's go at the tagged entry. Okay, now it's the time to align this stuff. Okay. So how do we add a tag to the tagged entry? Well, we have this function here, add tag internal. So the first thing we do is we store the tag inside the list store. This will take a reference on the tag itself. Okay. Okay. We'll also need to, yeah. Since the public API here, it's marked as transfer full. We could remove this transfer full ourselves. But in practice, yeah. Yeah. So in practice here inside the add tag internal, we call glist to append. This will acquire a reference on the tag object. And before returning, we call the object unref. So now the list store owns the tag. Pretty simple stuff. Now we need to create a tag view, the tag widget. So the tag widget is going to be something like this. New w type tag widget, and then it's going to have tag like here. Okay, the tag widget also owns a reference on the tag, which means that we need to remove the tag widget, and then we need to remove the tag from the list store when that happens. But for the time being, it's unimportant. So basically, at this point, if you did something like this, tag entry add tag, something like this. So if this is the calling code, AW tag new returns a tag object with a reference count of 1. append adds 1 because it acquires a reference. Gbobject new on the tag widget, passing the tag adds another 1, which means we get to 3. But now we remove the tag here and we go back to 2, which means the list store and the tag widget own a reference on the tag object. Then when we remove the tag, we drop the tag widget, which drops the reference on the tag. So go back to 1, and then we remove the tag from the store. Tag reference count goes from 1 to 0. The tag is collected. So no leaks. The reference counting takes a while to get inside your head, and there are a bunch of cases where I still get it wrong. So if you ever get wrong reference counting, do not worry. People that have been coding in Gbobject for the past 15 years also get it wrong. Nearly 20 years now. But yeah, we still get it wrong. So if you ever get it wrong, don't let imposter syndrome just get the best of you. It's literally what happens to everyone. So at this point, we have a tag widget. We want to add it to the flow box. So GTK flow box append okay, so we appended it. That's fine. Let's see. Now we want to bind the tag to the tag widget, so we can go from one to the other. So the tag widget has a tag field. Let me go back here. As a tag property, essentially here, that we can always go back to. We could even, yeah, no, we can keep it that way. So theoretically, whenever we remove a tag internally, where is it? Tag entry here. So whenever we want to remove a tag, we could do this. Okay. So first, we could do for okay widget child equals GTK widget get first child. So tags box. While child not equals null. GK widget next equals GK widget get next sibling. Then we take equals next. So let me see. ADW tag widget. No, we cannot do that. Flowbox is a flowbox child, so we need to do this. Okay, widget. Let me double check first. Flowbox child. Get child, yes. So it's going to be this. A flowbox get child. So the complication here is this. Whenever you add a child to a GTK flowbox, just like it would happen to a GTK listbox or GTK scroll window or other widgets inside GTK, what happens is you're not adding the child directly to that container. The container will interpose a child by itself. So if you do GTK flowbox add, append, whatever, GTK flowbox will take the widget that you're passing to it, create a flowbox child around it, and then put your widget inside it, and then add the GTK flowbox child, unless you're passing a GTK flowbox child, of course. This means that you cannot just remove children from a GTK flowbox if you have a pointer to the child you added. You have to get the flowbox child out of the flowbox and then get the child out of the flowbox child and compare it. And then if you do this, tag, we need to add API for that. So if tag idw tag widget get tag, then we can do GTK flowbox remove. Yep. And it's going to be GTK flowbox box, and then we remove the child. And then we break there. So this is not great, but it's still kind of good enough. So we iterate over every single child inside the flowbox, which is a private child, is a private widget for us, so we don't have anything that can be manipulating it from the outside. And then we remove the tag view, the tag widget. Since we remove the tag widget, the reference count on the tag goes -1, which means that when we remove the tag from the list model, the tag reference count goes to 0 and the tag gets collected. This is not great. Another approach would be to spend a little more memory and have a hash table to map the tag to the tag widget. And then whenever we remove the tag, we get the widget out of the map, the hash table, and then we remove the parent of the tag widget, which is going to be a flowbox child from the flowbox. It could be worth doing it for another iteration over this, but for now, this is probably fine. So we go back to the window UI here and we add it back. Then we demo window here. And then we go into the demo window UI now. We need to go inside the page for the tagged entry, so yeah, we create another AW tag, first tag, first 0, and then we have this object here. So we remove this on our tag label, and that we do add tag new, then ADW tag set label, what am I doing here? And then we call ADW tag entry add tag, okay. So let's see if it builds. Nice. Whoa, what happened here? Probably an error in the header file. Yep. There's probably going to be another error. Yeah. Where are you? Undefined ephemeral. Oh yeah, but I'm an idiot. Okay, we have to go back into the meson build and add the entry. Here and the header file. Then we have to go inside the demo and undo this. Nice. Tagged entry. Where are you? Here. Here. No. Here. Okay. Yeah, of course, I need to do that. What? Yeah, I need to do a cast there. For now, we are doing this anyway, and I need to add this API. So tag widget private. We're gonna add a very simple AW tag. And then we go inside our tag widget here and we add API to do exactly that. Okay. Get tags. Yeah, I botched the name. It's gonna be get tags. Let's see what happens now. Oh, we're missing a constructor. Okay, tagged entry 254. Now these are inconsequential, and tagged entry. Wait, what? Tag new here, okay. Oh, I didn't add a constructor, yeah. That'll do. I also might need to add the ADW tag to the widget. Yeah, it's missing the tag entry. Okay. Introspection bits are fine. Okay, let's see what happens. Ooh, okay. Okay. Right. Yeah, I'm setting the name, not the label. There we go. This one goes away. Okay. Oh, tag widget has no property name tag. What? Okay. Tag widget. It has a property name tag. Yes, I'm an idiot. Of course it doesn't have it, because I never installed it. Okay. Okay, there's a gk get parent widget equals null. So what the heck is it doing? Okay. So tag entry. It's going to be in tag widget. Because again, I'm an idiot. It's the opposite. I'm so used. So this is how stuff breaks your mind. I'm so used to DOM-like APIs where you add a child to a parent, then set parent. I keep using set parent as a add child, but set parent takes the widget you want to set the parent for. So it's not I particularly like this API. I wouldn't have implemented this way. And there we are. So if we add a tag, here and here. Okay. So the mechanism still works the same way. Of course, we'll need to fix the styling. That is inconsequential at this point. Doesn't really matter. So we'll have to figure out the icon here if we want to show it if the G icon is unset. But for the time being, it's fine. Again, styling is going to be its whole thing. And we, of course, have to figure out a way to deal with this, but again, that's fine. So I'll have to deal with that as well, but again, that's fine. So what we are going to do is we'll have to deal with the actions and stuff like that. So that, again, that's fine. Yeah. Let me run this under. Okay. Okay. How do we run it? Okay. So we're going to do references, environment, runtime environment, G debug, fatal radicals. Then we do GTK a none. And then we run it under the debugger. Okay. Oh god, yes. It has to rebuild everything. Okay. There you go. Widget dispose. Here. Object ref G's object failed. Okay, why is it failing there? Probably because we're doing something impressively stupid, but that's par for the course with me. So dispose here. We clear the object of the tags. Oh yeah, we need to clear. We need to. Let's see if this fixes it. Ordering issues are annoying. No, it's still there. It means we are dropping one reference too many. Yeah, we're dropping the reference there. Let me double check GLI store append what it does. Okay, we need to go inside GIO. This store append. Oh yeah, No, it does. Oh no, the function takes a reference on the item. Yes. Mm-hmm. Yeah, we'll have to fix that anyway. Remove that. Oh, I'll have to also drop the auto pointer from here when I commit it. Mm-hmm. Let's see if I miscounted. I think I know what the problem is. Yeah, I know what the problem is. I'm doing this here, but the object, the first tag I added, it's added from the GTK Builder UI, which means that I really need to add back this argument here. GTK Builder will own the reference on the tag object, and then because it's a child and it's assumed that child definitions are widgets, so it will drop the reference by itself. The main problem is that we also drop the reference, which means we have a one reference too little. But our public API instead behaves differently, so because it's transfer full. Pretty sure that's the problem. So if I do this, yeah, that solved it. Always be careful with the buildable overrides, because if you do that, then you need to deal with this stuff. You need to deal with the fact that GTK Builder is the original owner of the reference, and it will drop references when it goes away. So it already acts, it acts as a transfer none. So the ownership doesn't get transferred to you, it assumes you are going to take the ownership yourself. Whereas the public API we have will explicitly transfer the ownership from the caller to the callee, so from you to the function. Whereas GTK buildable add child will instead assume that you will increase the reference count, so you will acquire a reference yourself, so the ownership is not transferred. The problem is then GTK Builder will drop the reference when it goes away at construction time. And this means that we only add one reference. So we either add the reference on the glist store, or we add the reference on the tag widget. And then whenever we remove the first one between these two, the reference count on the tag object would drop to 0. But okay, yeah, basically this is the, I think this is the final form of this API. Of course, there are a bajillion other things to do, but this is kind of a final form. Hi, Zuku. Thanks for the follow. But yeah, this iteration of the API, I mean, the remove all stuff is going to require removing all the children of the flow box as well. Let me see if I can get a flow box has remove all. It does not. So we'd have to do this. Save tags box. Well, child not equals null. It's going to be child. Then it's going to be child equals next. And then we're going to do GTK flow box remove. Okay. So remove all tags is going to be that way. We can also have that inside our demo. So we can do something like this. And then we can go inside our here demo page. And then here, signal connect, all button. And then here we can go void on remove all. Yep. And we can do ADW n3 remove all tags of entry tags here. And here we go. There you go. Done. Oh, yeah, that was okay. Yeah, there are a couple of things that should be improved. The first one is avoiding the linear behavior of well, we still have a linear behavior inside whenever we remove the tag from the model, because we need to iterate over every element of the list store. But also it would be nice not to have the linear element inside the flow box in order to find the widget that is associated with the tag. For that, as I said earlier, we could use a hash table to map those two elements using simple pointers. So whenever we remove one, we remove the other, and it's pretty trivial. It's a pretty trivial thing to do. After all, the flow box is already holding a reference on every single tag widget, so we don't have to complicate this thing any more than it's necessary. Yeah, it's a pretty simple change, like g hash table tag by widget, and then we create inside the instance init function it's a simple direct mapping, and we do this. Yeah, this is fine. Yeah, so we do ATW tag widget, sorry, yeah, we do tag here, and if tag widget equals null, we do g critical no widget for here, and then we do GDK flow box remove. Okay, this is going to be soft box GTK widget, yeah, and let's do this. That's a lot easier to deal with. We'll still need to do this because it's necessary. And whenever we add a new tag, here we do g hash table insert self tag by widget tag there. Again, pretty trivial. The probably hash table should be called something else. Widget for tag. Is a good name, widget for tag? Yeah, let's call it widget for tag. And the same is going to be used here, widget for tag. Yeah, tag by widget. This is going to be a widget for. Also, we'll need to free it when we dispose everything, so it's going to be g clear pointer self widget for tag. Yeah. And there you go. Yeah, same mechanism, but now we avoid full iteration over the children of GTK Flowbox. You know, to do a simple pointer comparison. That's a bunch of work that we now have to do. But yeah, at this point, the API is, I think, what I want it to look like. Let me close a couple of things here. Okay, here. So we have the tag object. We might have additional convenience API. For instance, for creating a tag with a label and an icon and the close button all inside the constructor function, for instance. Or having more API for the icon or the paintable, so you can choose more things to set. Then we need to implement the action name and the action emission in general, so that the tag can emit an action whenever it's activated in some way, which means that we will have to implement the actionable interface and a bunch of other things there, so you can activate it as an element. Another thing that we will have to do inside the tag is adding a gesture, so a click gesture, so you can click the entire tag and not just the close button. So you click the entire tag and you activate the action. Again, pretty simple, fair. Then we have the tag widget. The tag widget is a private widget that only represents the state of the tag. So the icon, the label text, whether or not to show the close button. And it does it by literally doing property bindings. Yeah, if we add a paintable property to the tag object, then we'll have a paintable property binding between the tag and the image here. And there's nothing more than this. It's pretty trivial. And then we have the tagged entry. The tagged entry is going to be, again, it's another fairly simple widget, but we might end up adding API here to do the matching of tokens. So it's kind of like the NS token field in AppKit. Basically, you'll pass something like this. Let's prototype it a little bit. It's going to be something like AW tagged entry set tokens, and it's going to be so you pass a glist model of tokens, for instance, GTK string model with a list of strings. That's pretty much it. Then you're going to have an ADW tagged entry set match function that basically let me see if glib already has a not a comparison but a match. Oh, not match info. No. Yeah, we have a G compare func, but this is a comparison, so it's for sorting stuff. Let's say although so let me see. Like a filter list model, maybe. GTK filter, yeah, okay. Yeah, maybe oh, okay. Yeah, we can have a set filter, like set filter match. Yeah. So, set filter. Yeah, set tokens. You take list model and you also take a filter object. Yeah. So basically what you get is you pass the source of tokens and the filter object that will do the matching between the contents of the model and the filter and the and what the entry currently contains. So every time you enter something inside the entry, we will take what you entered and you press space, for instance. So you type foo, press space. At that point, we take the part that you just typed and we match it against the model here. And if there is a match, then we remove what you just typed and we put it inside a tag. So this is kind of the tagged entry that I'm thinking about, that I'm envisioning when I see something like this happening. The list model can be arbitrarily complex, so you can put, I don't know, your contact list, and then whenever you type the email address or the name, it will do a match on we're using the filter object, and once you do that, then you can get the tag, so to speak, to replace what you just typed. So it's kind of an auto-completion, but it's not really, because it's a precise map to a point. It doesn't show you the list of potential completions. It just, once you match something, then we replace it with a widget instead of still being text. But yeah, this is kind of how it looks like to me, this API. Yeah. yeah, basically, yeah, kind of like this. You take a model, you take a filter. It's not a filter list model because we are not showing the list of filter elements, but we're gonna do something like this. So we take a model and we take a filter here. Yeah, I think that kind of matches what AppKit uses, using the token field, the NS token field. Okie dokes. So let's switch back to my head because it's been almost 3 hours. So we can close here right now. We are going to do something like this. Yeah, on Friday I'm going to look at the styling of this thing. So I'll have to modify the widget style to display the tag widgets as like pillboxes, and change the styling of the close button and the icon, add more margin in case the button is not there. But yeah, that should be fun. Plus I will add a couple more API entries for the, as I was saying, the paintable, and here and there tweak the API. And then I will try to figure out if we can implement the tokenization. So doing filtering on the text entry and then matching a list of possible values with a filter object. Yeah, at the end of the day, yeah, you can. So the tricky part is that you're gonna have some text, and that text must match some other object. So at the end of the day, we will have to create a string object and compare that string object with the contents of the list model, generic list model. So you can have a list model of contacts, so a list model of objects, complex as much as you want, and then you can match the string object to the contents of that object. So name, email address, whatever. You can also have complex things like I'm going to type tag colon foo, and then that tag colon foo gets matched against a model of tags, for instance. So you could have a more complex list model where there is a tree of list models, or a bunch of different list models that are chained together. The model API inside GTK is pretty complicated, and it's fairly extensive in its implementation, so you can do fairly complex things with it. But I don't want to make it too much complicated, otherwise it's going to be a massive foot gun for everyone involved. Okay, though, I think we made good progress. We re-implemented the tagged entry using the new API and new model with a separate object and a separate model object for the tag, and a separate view object for the widget that represent the tag, and then we rejiggled the tagged entry API to match that. So, time for the usual YouTube outro, which is, if you enjoy watching me struggle while fixing or implementing new features of the GNOME software development platform, or documenting the software development platform, then why not subscribe to my YouTube channel? Or if you want to watch me struggle live, then just follow me on Twitch, twitch.tv/ibasi, and you will get notified every time I start streaming, which is on Monday, Wednesday, and Friday at 4 p.m. British Standard Time. Now, for everyone who is still here, thank you very much for following along. I hope you have a great rest of your day. Enjoy your Wednesday, and I shall see you all on Friday. Bye.